5.2, slope and direct variation. We're going to be comparing slope with direct variation and finding out the constant of variation, and we're going to be graphing those direct variations. All right, so remember that slope is the rate of change in y's over the rate of change in x. Or we've also written this a couple times. Let me find the color. Delta y over delta x. That's a little triangle, sorry. And that is the rise over the run, which is the y's over the x's. Well, how is slope related to your shower? Did you know that a standard shower head uses about 2.5 gallons of water per minute? What is the constant? What is something that never changes in that statement? Is it the hot water, the cold water, or the gallons per minute? Which one is it? Yes, the 2.5 gallons per minute. That is the constant. It doesn't change unless for some reason you have, a break in the water line down the street and then you don't have any water. But the 2.5 stays pretty much the same. It is constant. So that would be the gallons per minute. All right, so let's make a table and graph it. And let's start with some points. Now, any point. Now, when we're talking about a shower, when you get in there, it's not already running, right? So you're going to start at 0, 0, which is right here. Okay, that's before you've turned the shower on. And we're going to be doing this per minute. So I'm going to space this out. 1 minute, 2 minute, 3 minute, 4, 5, and 6. All right, so 1 minute, 2 minutes, 3 minutes, 4 minutes. X will be my minutes. Let's label that. And the y-axis is going to be my gallons. Okay, so at 0, of course, it would be 0 because we haven't started the shower. And this said that at every minute, there is 2.5 gallons of water that have been used. So at 1 minute, it would be 2.5. So at 2 minutes, what would it be? That's right, you just multiply 2.5 times 2 because it's been 2 minutes. That makes 5. All right, so then you add 2.5 more minutes to that. We'll give you 7.5. Add 2.5 more minutes to that, and you will get 10. So after 4 minutes, you've used 10 gallons of water. That's not too bad after 4 minutes. You would think it would be more than that. I believe they said that, used to be that it would be, they're not as, weren't as efficient as they are now, so they used a lot more water. All right, so let's graph that. At 1 minute, it is 2.5. So at 1 minute, there is, I'm going to make this 1, 2, 3, 4, 5, oops, 6, 7. I'm going to run out of room probably. That's all right. So at 0, 0, we start, and then at 1 minute, we're going to be going 2.5. So that's right here. Here's 1, 2.5 is right there. Put a dot. Okay, and then at 2 minutes, it's going to be 5 gallons. Roll up this line. At 3 minutes, it's going to be 7.5 gallons. Right there. And at 4 minutes, it would be 10 gallons, which would be off my chart. That's okay. We can put way up here. Be about right there. And you can draw a line. You can see that this will make something linear. Okay, it's following the pattern. Okay, there's your linear graph. All right, and that's pretty consistent because every minute it's doing the same amount of changes in the x value and changes in the y's. Okay, so every time it goes up 2.5 minutes, excuse me, 2.5 gallons, it's going over 1. 2.5 and over going 1. Okay? That means it's going to have a direct variation or a direct constant of variation is what I'm trying to say. All right, let's go on to the next slide, and we'll talk more about it. So we can represent something that is a constant in an equation, and we call that direct variation equation. This equation is y equals kx. You need to memorize this one. We have a lot in this chapter where you have to memorize. Okay, where k, this k right here next to the x, is our constant of variation. K will never change once you determine what it is in a particular problem. Okay, once you have that constant in that particular problem, it is going to stay the same. K and the slope are the same thing in a direct variation. So if you remember that the slope was always in front of the x, that's also considered the constant if it's a direct variation. And when we graph this, the direct variation equations will always pass through the origin. And remember, the origin is right here in the middle between where the x and y axis meet. That is the origin. That's where you will always go if it is a direct variation. If it is not a direct variation, it will be moved somewhere away from this origin. All right, so given y is equal to 3x, okay? What is the constant of variation, or what's k in this particular problem? Because we see that it goes through the origin, and it is labeled right here, y is equal to 3x. So that we see that it's going through the origin, so in this case, k is 3. Okay, if k is 3, that means in a direct variation that the slope is also 3. Remember, in a direct variation, k and slope will always be the same. Okay? Excuse me. Okay, it's not cooking. All right. Example graph this equation, y is equal to negative 1/3 x. Okay. First step, you will write the slope as a fraction if it's not in that form already. And it happens to be that this one is in fraction form. Okay, but if not, remember you can put any number over top of 1 and now it's a fraction. Okay, you will graph the point 0, 0 because all direct variations must go through the origin. And then from that point, from the origin, you will then use the slope to find more points and draw your line. Remember, it's always rise over the run, which means up, down first, and then out right. Okay? Up, down first, and out right. So, I'm going to go to my graph, and I'm going to put the point at 0, 0. This is for direct variations. And then my slope says negative 1/3. Okay, that means I'm going to go down, treat the y-axis like it's an elevator, go down 1 and out right 3. Put a dot. Down 1 and out right 3. Now you can also go, as long as you're following this line, you can go up backwards, right? And draw your line. And there's your line. Pretty easy. All right, so how do you know if an equation represents a direct variation? So you're going to be given equations. You're going to have to know, is that a direct variation? In order to do this, you have to solve for y. If it's not already solved for y, you must do it. So looking at these equations right here, are these direct variations? And if it is, then you're going to tell me what the constant of variation is or the slope. Okay? The first one says y is equal to negative 5x. Anytime you have anything in y equals, remember, you can graph that in your calculator and look at it if you need to. But I know that this is going through the origin. It's in the form y equals kx. It doesn't have anything else outside of y equals kx. There's nothing extra added to it or subtracted to it. So I know that this is a direct variation. So if that's a direct variation, then the constant of variation for this particular one is negative 5. So K, change my color, K is equal to negative 5. That is my constant of variation. Okay? All right. Letter B says 2x minus 3y equals 12. Well, we know that's not in y equals form, so we need to make it in y equals form. So I'm going to go over here and I'm going to do my work over to the side of my paper. So it's 2x minus 3y equals 12. Okay? I'm going to subtract the x first. That is always the rule. When you're solving for y, x gotta go first. Okay? Get rid of the x's. Right, so now that just leaves me with negative 3y is equal to, and I told you always, always, always put the x first. Now you're going to see why. Negative 2x plus 12. And then I'm going to divide everything by negative 3. Everything needs to be broken up like this. All right, so then y is going to be by itself, and it's going to be a negative 2 divided by negative 3, make a positive 2/3. Put your x, that's very important. And 12 divided by negative 3, make a negative 4. Now, the question was, is that a direct variation? Well, in order to be a direct variation, it has to be in the form y is equal to kx. But I got extra stuff over here. And if I graphed it, I would find it wouldn't go through the origin. Okay, and you can check those with your calculator. Just put in y equals. So this one is no, not a direct variation. All right, the next one, C, says 5y equals 3x. Well, I need to get in y equals, so I need to divide everything by 5. So this one will be y is equal to 3 over 5x. Right? Now, is that a direct variation? Well, it's in the form y equals kx. There's nothing else with it. If I graphed it, this would go through the origin. So this is a yes. And my k would be 3 over 5. And my pen's not working. What is wrong? 3 over 5. There you go. 3 over 5. That's what k is. All right, next problem. We have 35 equals y over x. Now, that's not exactly the right form, but can we make it into y equals? We've got to get rid of this x. If it's dividing right now, how do I get rid of division? That's right, we multiply. So if I multiply both sides by x, then that will get rid of the x over here, and that'll leave me with just y equals, and then this side would be 35x. All right, so that's in the form of y equals kx. So this is, yes, a function. Excuse me, not a function. Still on that chapter. Yes, this is a direct variation, and my k would be 35. Okay? All right, how about this one? We have to get y by itself, so we need to divide by x. Divide by x. This one ends up being y is equal to 20 over x. Now, is that in y equals kx form? No, this one is not. Okay, this one is not a direct variation. Okay, so this would be a no. Cannot have the x on the bottom for a direct variation. All right, and the last one, similar problem. This is already solved for y, and we have an x in the bottom. If we multiply both sides, we get xy equals 3. That still doesn't help us. This is a no. Cannot have the x on the bottom. Okay? All right, what about tables? We're going to be given these situations in different formats, just like we did with the functions. We're going to have tables, we're going to have graphs, we're going to have ordered pairs, we're going to have equations. You name it, we're going to have it. This is an example of a table. And remember, always the x would be on top, no matter what letter they designate it, and the y, as far as we're concerned, is on the bottom. All right, so when you have a table and you need to see if it's a direct variation, you need to take every single one of these, and these are technically ordered pairs, remember, 30, 3, 40, 4, 100, 10, because it's x, y. You need to take every single one of the y's and put it over top of the x, because we have to have it in fraction form, rise over run. Rise over run. All right, so we're going to put each one of these in fraction form, starting with my 3 over 30, 4 over 40, 10 over 100, and 20 over, I didn't write very well, 20 over 200. And we're going to divide each one of these and see what we get. When you divide 3 over 30, you get 1/10. When you divide 4 over 40, you get 1/10. Remember, we don't do decimals, so make sure you hit math enter, enter. 10 divided by 100 is 1/10. And then 20 divided by 200 is also 1/10. Now, if all the numbers in the table have the same ratio, then you will have the same constant of variation, which is going to be 1 over 10. So if that's the case, that's what k is, 1 over 10. Okay, so then our equation just simply written, y is equal, and we replace that k with what we got, which is 1 over 10 x. So the equation for this is x equals 1 over 10x. That's all you do. Once you find k, then you will put that in for your slope, y equals whatever that is, and x. That is your equation, as simple as it can be. All right, let's go to the next slide. All right, so now you're going to be looking at a graph. Okay, really, really easy to do the graphs. Which one is a direct variation? Remember, direct variations must go through what? Origin. That's right, and origin is dead in the middle of your graph. Okay, so which one goes through the origin? Which one goes to this point right here? This one does not. How about this one? Yes. Where's my pen not working? And then this one does not go through the origin. This is the line, but it does not go through origin. This one is not. So this one is the only one. Now this one's a negative one. That's okay. They can go through either way, negative or positive, and that'll be fine. As long as it goes through the origin, it's a direct variation. All right, so now you're going to be given a set of ordered pairs, which might make a direct variation. Well, you do just like you would a table. You're going to set each one up as y divided by x, okay? Remember, this is your x, and this is your y in every ordered pair. So I'm going to go ahead and set these up. This one's going to be 3 over negative 4. This one's going to be 2 over negative 6. This one's going to be 16 over 4. This one's going to be 12 over 3. This one's going to be negative 8 over negative 2. This one's going to be 9 over 3. This one's going to be 4 over 4. And this one's going to be 12 over negative 1. And then you divide each one of these and see what they are. If you divide 3 by negative 4, you're going to get a negative 0.75. If you divide 2 and negative 6, you're going to get a negative 0.33, repeating, I think. 16 divided by 4 is 4. 12 divided by 3 is 4. Negative 8 divided by 2 is a negative 4. 9 divided by 3 is 3. 4 divided by 4 is 1. And then 12 divided by negative 1 is negative 12. Okay, so go back and look and see which ones would make a direct variation. Okay, I've got 2 of these right here that made 4. Right, let's see. Oh, I know what. I forgot. This should be a negative 2. This should be not a negative. This should be, let's see, fix this. This should be a positive 4. Alright, let's go back and fix that. Alright, so I have 3 numbers right here that are the same number. That means they are, and they would make a direct variation. So I would take those points, and what point made it was 416. Why is my pen not working tonight? Alright, and then the next one was 312. And the last one was negative 2, negative 8. And those are the 3 that would make a direct variation. So you have to divide each and every one of them in order to find that. Okay? Now we're going to write direct variation equations. Now these are not bad, especially since we've done so many word problems. You should be much better at these than you were when you first started. You're going to be given equations such as this. This is one whole problem right here. If y varies directly as x and y is 24 when x is 3, find y when x is 4. Oh my goodness, it looks like it's a mess. But really, look, you notice it's broken up by these commas. This is like the first part. This is the middle. And then the last part. And you're going to do each little section one at a time. Okay? That's the best way to describe it. Break it up into 3 parts. Do each part separately. You're going to use y equals kx formula for the direct variation. Then what you're going to do is substitute in what you've been given, reading left to right. And then you're going to find K because she's missing again. I know it's a funny joke, but K is always missing with direct variations. We're always looking for her, and we have to find her first. And then once you find her, you're going to write your direct variation equation. And then using your new equation, you're going to find the missing parts. Okay? So let me show you what I mean. Always write your equation for a direct variation first. Okay, that will take care of this whole first third of this sentence. Okay, if y varies directly as x, that's what that means. Y varies directly as x. Why did I put a W? Thinking about food or something, I don't know. and W should be an X. Oh, goodness gracious. All right. All right. So then you're going to look up here for the second half or the second part of your sentence. It says y is 24. So I'm going to go down here instead of y, I'm going to put a 24 equals, we don't know what k is, we've got to find her, but we do know what x is, and x is 3. So I'm going to plug that right here. So then you solve for k. That way we find her. So you're going to divide by 3, divide by 3, so k is equal to 8. Now, we finished the first two parts, and now we're ready to finish up the whole problem. I'm going to go ahead and put k as 8 over here since we found her. All right, then you go back to your equation, y is equal to kx. Now we know what k is, so I'm going to put that in my problem. But now it says up here, find y. So that means we don't know what y is, leave it alone. When x is 4. Okay, so now I'm going to put 4 in for x. So you just multiply those two. Y is going to be 32. And now you're done. So what that's saying is, when x is 3, y will be, when x is 4, y will be 32, based on that direct variation, based on the constant of k being 8. Okay? Very, very easy to put into your problems. All right. Let's see if I have any more. Yeah, I do. Let's practice. Let's do one together. All right. If y is equal to 9 when x is negative 3, find x when y is equal to 15. Now, sometimes they don't give you the beginning problem that says y is equal to kx. So you just write it. Okay? That would take care of my first little part of the sentence. Now it says if y is 9, I'm plugging in, we don't know what k is, we got to find her first. Negative 3 is what x is. Alright, so we need to solve for k. She's a very needy person, apparently. Alright, 9 divided by negative 3 is negative 3. Can y'all see that? Let me write it down here. Negative 3 is what k is. Alright? Now it says find x this time. Alright, so we don't know what x is, but y this time is 15. So I'm going back to my problem. 15 equals, we know what k is, and we don't know what x is, but we're going to find it. Okay? Divide by negative 3, solving for x. This will mean that x in this problem is negative 5. Okay? Alright, let's try another one. It says if y is 125 when x is negative 5, find y when x is 10. Alright, again, you use your y is equal to kx. Clear y is equal to kx. Y is 125 when x is negative 5, and we're looking for k again. She gets lost a lot. Divide by negative 5. K is going to be, let's see, 125 divided by 5 is going to be 25. No. Oh my goodness, 5. Hold on just a second. Talking about all this food and I'm just getting hungry. 125. Can't do anything today. Negative 25. That's what I was thinking. I was going, what? Alright, so then k is going to be negative 25. Alright, if k is negative 25, it says find y. We don't know what y is, we make it a y. K is negative 25, and x is 10. So that's just multiplication, so this one's going to be y is negative 250. Okay? Very, very straightforward. You do need to show all your work. You do need to do all your steps. This is not one that you want to skip around and do some of it in your head, some on the calculator, because you have a tendency to get lost. All right, so then you have tables again. Remember, you always want to do y over x because it's rise over run. Okay? So we need to take each one of these and put it in that form and check each one of those and see if it's a direct variation, if the constant is the same all the way through. If the constant is not the same, once you get one of them that's different, you don't have to do any more. It's done. It's not a direct variation. So I'm going to do 6 over negative 2, 3 over negative 1, negative 9 over 3, negative 15 over 5, and I'm going to see what that is. 6 divided by negative 2 is negative 3. 3 divided by negative 1 is negative 3. Negative 9 divided by 3, negative 3. Negative 15 divided by 5 is negative 3. So this is yes, and then the constant of variation would be negative 3. Let's see what this one is. 6 divided by negative 4, 9 divided by negative 6, 5 divided by negative 5 divided by 10, and negative 18 divided by 12. All right, 6 divided by negative 4. Make sure when you put it in there you hit math enter because you want to know what it is. Negative 3 over 2. Or really you can compare decimals, it doesn't really matter. I'll write the decimal if you want to see the decimal. All right, 9 divided by negative 6, negative 1.5, negative 5 divided by 10. Oh, that's negative 0.5. All right, we already have a difference, so this would be a no. We can stop right there. We don't have to go any further. It has to be all the way across for it to be a direct variation. Okay. And that's it. All right, so we will practice in class with direct variations and continue talking about slope. Do your homework. See you then.